right, welcome back for video 3. We are going to be talking today about transformations on the coordinate plane, and today's transformation focus is going to be a rotation. So hopefully you guys are earning your way out of Redemption Island today, watching this video at home so you're prepared for class tomorrow. So let's start by defining rotation. In math class, rotation is the exact same thing as it is outside of math class. When we rotate our tires, that means we're turning our tires. So rotation, the definition that you need to get copied down is a transformation in which a figure turns around a fixed center point. So go ahead and pause the video and get that copied down. Okay, so a rotation is considered an isometric transformation, which remember means it doesn't change the size or shape of the figure. The image will be congruent to your pre-image. The only thing that's going to be changing is the position in the coordinate plane as well as the orientation. So it might be upside down or backwards, but it will still be the same size and the same dimensions. Okay, and for today, that center point that we're going to be rotating around is going to be our origin, the point 0, 0. It doesn't always have to be that point, but that's kind of going to be our focus for this unit. All right, so go ahead and in your booklet, turn to page 12. Okay, should look like this. And we're going to start, as always, by plotting our original point. So my pre-image is S is at 2, 2, meaning I'm going over 2 and up 2. T is positive 4, positive 2, so I went to the right 4 and then up 2. U is positive 5 and up 4, so I went to the right 5 and up 4. And then V is positive 1, positive 4. So here's my original image. All right, and before we start rotating, there are a couple of things that I want to point out to you. One is that when we're rotating a figure, you're going to be given two pieces of information in the problem. The first piece of information is how far am I rotating this? And usually we're going to be rotating in increments of 90 degrees. So if you think about on the protractor, 90 degrees is going to be from here to here. Or 180, which would be the entire way. You'll also see 270, which would mean you're going to be down here. If I had a full circle protractor, you'd be able to see a 270 down here. And then sometimes you'll see 360, which basically just means you're going to be back at the original point. We call that mapping it onto itself. The other piece of information is you will see problems that say we're rotating either 90 degrees clockwise or 90 degrees counterclockwise. When we talk about rotating clockwise, that means that we're going the same direction as a clock. So if this clock had a battery in it that worked, then that means we would be rotating in the same direction as that second hand on the clock. Counterclockwise means just the opposite. We would be going the opposite direction of that second hand and the minute hands as well. And the protractors actually give you both of those pieces of information. So if my point is here and I'm rotating 90 degrees clockwise, then I'm using this inside measurement. Counterclockwise would be more like the outer measurement. All right, so let's then go back to page 12. You will see counterclockwise abbreviated with this little CCW, and when we write clockwise, it'll usually be written with a CW for clockwise, not the TV channel. All right, so I want to show you kind of visually, before I start talking about the rules, what this would look like. So when I rotate this, I've got this little image here. When I rotate this 90 degrees around the origin, that means that I'm going to be taking this and rotating it basically just into the next quadrant. So it's going to look like this. I've taken this entire shape and I've turned it around. That would be 90. If I want 180, then I'm going to go down again to another quadrant, and it's going to look, oh, I lost my point. It's going to look basically like this. And then 270, we go again. And then if I did 360, it would put me back into my original position. That's rotating counterclockwise. Now I want you to notice that if I rotated this clockwise, 90 degrees. It ends up in the exact same place as what the 270 degrees counterclockwise was. So, and 180, regardless of clockwise or counterclockwise, it looks exactly the same. And then if I rotate 270 clockwise, then I end up in the same place that we got for counterclockwise when we went 90 degrees. So they're kind of opposites in that way, and you can use that information to your advantage when you're trying to remember these rules. All right, so let's see if my little visual demonstration works out with the math. So my first ordered pair is, I'm actually going to skip the first one right now and start with V. The rule for rotating counterclockwise 90 degrees, we've got it written down for you here. It says negative yx. And remember, in an ordered pair, your numbers are usually x and y. So if I want to change that to be negative yx, that means I'm going to flip my x coordinate and my y coordinate. So instead of 1, 4, it's going to be 4, 1. And also, instead of whatever the original y was, I'm going to change it to its opposite, just like we did with reflections. Let's see if I can get this a little bit. Nope. I'm not going to be able to make it any better, sorry. Okay, so my original y value was positive 4, so when I make that into its opposite, it's going to be negative 4. I'm going to do the same thing with u. I'm going to flip the order. So 4 becomes my x, and 5 becomes my y. And I originally had a positive 4, so now I'm going to have a negative 4. When I flip this one, instead of 4, 2, it's going to be 2, 4. My 2 was originally positive, so the opposite of that is negative. And then the reason I didn't start with this one is because flipping 2, 2 still leaves you with 2, 2, like a ballerina. And my y value was positive, and now it's negative. Okay, so let's go ahead and plot those coordinates. When I do negative 2, positive 2, I'm going to the left 2 and up 2. That is my S prime. When I do negative 2, 4, I'm going to the left 2 and up 4. That is T prime. When I do negative 4 for U prime, I'm going to go to the left 4 and up 5 for U prime. And then V prime says negative 4, positive 1. So there's V prime. And when I connect those points, I end up with a rotated trapezoid. So it's the same size trapezoid. It takes up the same amount of space, but it's in a completely new position, and it's a completely new orientation. And it does, if you remember my nifty little trick here, it does fit exactly, if I didn't move it, exactly where we expected it to be. Okay? All right, so let's go back up and look at the rule for rotating 180 degrees counterclockwise. So that is going to keep our numbers in the same order. Notice it says negative x, negative y. I'm just going to write it a little bigger for you. So the order of the numbers is going to be the same, but now I'm changing both of their signs to negative. So looking back at that pre-image, I'm still going to have 2 and 2, but now it's negative 2, negative 2. Instead of 4, 2, it's going to be negative 4, negative 2. The order of the numbers is staying the same. The only thing I'm doing is changing all of them to their opposite. If one of these had been negative, then I would have changed it to a positive over here. So this becomes negative 1, negative 4. Oh, I should have switched colors. Sorry about that. We're going to do black for this next one. Also, these are going to be labeled as S double prime, T double prime, because this is now my second transformation on this pre-image. So when I plot those, I'm going to do this very quickly. I'm going to go to the left 2, down 2. There's S double prime. I'm going to go to the left 4, down 2. That's T double prime. I'm going to go to the left 5 and down 4 for U double prime, and then to the left 1 and down 4 for V double prime. Okay, and again, you can go back and look. That's exactly what we predicted when we were using our little visual method there. And basically, I've taken this and spun it around 180 degrees. All right, the last one says to rotate that pre-image counterclockwise 270 degrees. The rule this time has y negative x. So I'm again changing that order, but this time I'm making the x value negative, and that's because we're expecting it to fall in this fourth quadrant here. Okay, so changing the order of 2, 2 still leaves me with 2, 2, but I'm changing my positive to a negative. Again, I'm going back to my original coordinates, my pre-image. T is 4, 2, so I'm going to change that order, and I'm making that positive 4 into a negative because I want this to be the opposite. U is 5, 4, so I'm going to switch the order, and this positive 5 is going to become a negative 5. So it's 4, negative 5. And then V is positive 1, positive 4, so when I flip that, it becomes 4, negative 1. Okay, so let's go ahead and plot those. This, by the way, when I label it, is going to be triple prime. This may be the first time we've come across a triple prime, but we're just putting 3 little dots there. Or not dots, but little apostrophes. Okay, so let's plot those then. I'm going to the right 2, down 2 for S triple prime. I'm going to the right 2, down 4 for T triple prime. I'm going to the right 4 and down 5 to get U triple prime. And then the last one is going to be positive 4, negative 1, and that's V triple prime. So when I connect these points, I get the same exact trapezoid that's just been rotated one last time. So if we look at all 4 images, here's my pre-image, and then the first prime, double prime, and triple prime. And again, that's just rotating that little guy all the way around the coordinate plane. And if I rotated another 90 degrees, I would end up right back to my original location. All right, go ahead and check with your teacher. That's not what I meant to say, and I'm not going to record this whole thing again. Go ahead and look over review the video if you need to, and when we get back to class, we will test to make sure you watched it.